Hi there, this is the pre-show of Hot Off the Cloud, volume 10 already, Michael. So we're doing this for the 10th time
That's
in a
great.
row. So Michael, what have you been working on within the last week?
So I'm working on a new feature for our Marbot, which is our monitoring chatbot. So basically what it does, it sets up your monitoring configuration. It routes alerts to the correct people, and it also helps you to solve incidents. So with additional information, for example, like links into the AWS UI, it can provide runbooks and things like that. So what we saw our users struggle with was the initial setup. And in Marbot, it is either Slack or Teams based. So basically, when Marbot joins a channel, you have to follow a couple of steps to set up monitoring rules. And it turns out that this is actually quite complicated for many people. So what I'm doing at the moment is that the initial step gets much easier to do. So what happens now is that you basically launch a CloudFormation stack that creates an IAM role. And then we run Terraform for our customers in the background to create CloudWatch alarms and all kind of other stuff. So for example, Eventbridge rules, LDS event subscriptions, and basically we now create the monitoring configuration for our customers. And with this new feature, we hope that the kind of entry bar gets much lower. And also you can't forget to add the rules anymore because we run the Terraform apply every 6 hours. So that's what I configured at the moment. And that's it. I mean, if Marbot makes any changes, it sends a message to the channel so you get full visibility, but you don't. I mean, the Terraform state is on us. Terraform itself is on us. So basically, we take care of everything. We just create the rules for you. And you can specify the regions that you want to use, or where you want to see those rules to be created, and also AWS accounts. So we support multiple accounts, and in each account, multiple regions. And so that's what I'm working on. And it's actually kind of done, Andreas, at least for Slack teams.
Mm-hmm.
I deployed it to dev, so I haven't flipped the switch for production. The code is already deployed. I mean, I think we talked about this before. So not for real users, but for us, we can use it.
Mm-hmm.
And basically what I want you to do after the show is to give it a try and provide me the last round of feedback, because I mean, I demoed it to you a couple of times already.
Yes.
So this is kind of the last demo, and then we see how our customers react. So we have tracking enabled, so we see how many customers complete the steps, and then we can kind of see where they kind of struggle.
Yeah. Okay, yeah, I think that's a really big change for Marbot. So I think from the beginning, our approach was we do not want to configure anything in our customer's AWS account. So this was our initial approach. It was basically a push model. So we provided templates, CloudFormation or Terraform, that you could use to configure everything. But we never did that part of configuring anything in your account. So this was a little bit limiting the product Marbot in itself. And a few months back, we decided to basically give up on that principle and to make sure that Marbot is also capable to make modifying changes in AWS accounts to simplify things like the monitoring process, but also add some other features that we shipped in the past weeks. So basically, this sets us free a little bit and allows more features. So I'm really excited about this new automated monitoring for AWS resources. That's cool.
Yeah.
Very
so
cool.
Andreas, what was on your plate last week?
I was mainly working on, so besides a lot of content stuff, so we shipped another episode of the Builder's Diary last week with Lars and Florian from TechRacer sharing their insights into serverless development. I found that quite interesting because they were talking about more complex and especially long-running serverless projects. They're working on a serverless project that is intended to run for 30 years. So I found this really cool. So yeah, check that out. You find a link to that in the show notes and the description. And other than that, I'm currently working on what we call the AWS debug games. So the initial version, Michael, is something that you have worked on, I think maybe a year ago. And we decided to give it a second try. Basically, the idea is we provide challenges, broken AWS systems, basically. And the game is that you spin up the problem in your account and then solve the problem. And we provide some guidance, some additional materials to basically help you to achieve that goals. And the idea is that this is a good way to learn about AWS by solving real-world issues and also to demonstrate your skills. So that's basically what we are working on. And I'm working on, I've added another game, and I'm working on authentication and stuff. And as always, handling those JWT tokens and CORS, so cross-origin resource sharing, and this. So I'm going back into full stack development, and I was a little sidetracked by the details there, but yeah, I think I hope that we will ship this in December as well, before we take a few weeks off over the holiday season here in Germany. Yeah. So thanks those who already joined the live stream. Welcome. This is the pre-show. We are starting the Hot Off the Cloud show very soon, where we discuss the latest AWS announcements. If you have any questions, feel free to ask them in the chat. We will try to answer them either right away when they fit to the same topic or at the end of the show. So I'm excited about that. So Michael, I think, is there anything else that we need to discuss, or can we start?
I think we can start, yeah.
So let me find the right button to play the intro, and then let's go. Welcome to Hot Off the Cloud by Cloudonaut. We are your hosts, Andreas and
Michael Wittig.
Our weekly show is all about the latest AWS announcements and our recent experiences building with AWS. On top of that, we are answering your questions at the end of the show, so use the hashtag AskCloudonaut on LinkedIn, or send us direct messages on Twitter or on LinkedIn. In case you're watching this live, feel free to ask your questions in the chat. So Michael, this week we have had a deeper look into two announcements from AWS from the past week, or maybe a little bit before that as well. And so let's dive into them. So I looked this morning. I looked into an announcement. I think it was announced during reInvent, and then there was another announcement this or last week about that Fargate does now also support this feature, and this is about the ECS Service Connect. What is this about? So the ECS Service Connect is basically another option for building you could call it a service mesh. Or you could call it service discovery. So basically, it solves the issue of if you deploy multiple services on ECS in your containers, and they need to communicate with each other. How do you make that happen? So there are quite a few options, Michael. Do you want to start with some of them? So what are the options that come to your mind right away?
I think the ones that we use most often is either an application load balancer, or I think we have support for app mesh in our templates, but I actually haven't used it.
Yeah. So exactly. So I think the most obvious and the simplest approach, and I think it's also the the less hyped one. So it's basically just use an internal load balancer. That's what you can do. So if you have a service, you add an internal load balancer, and only services from the internal network from the VPC are able to access the load balancer. So this is I would say, the old school way of doing so, but it's I would say still relevant. And then there's a huge naming confusion. So AWS has changed the name for this second option a few times. It is now called ECS Service Discovery, and it uses Cloud Map in the background. And that's what we support in our CloudFormation templates, Michael, by the way. Yeah, that's
Okay.
very confusing.
I think I said
Yeah,
App
AppMesh is.
Cloud Map. I think this was renamed as well, right?
I don't know. I think AppMesh is just the
Or-
third option.
no.
This is another one.
Okay.
So service discovery is a very simple solution. And basically what it does is you configure it for an ECS service, and Cloud Map is nothing else. I would say it's nothing else than an interface to add DNS records to a Route 53 private hosted zone. So I think this is the simplest way to use service discovery with Cloud Map. So basically, whenever a new container spins up, it adds a new record to DNS, and then you can just use DNS for service discovery and talk to the containers directly. It's also possible to use Cloud Map with an API. So there's an HTTP API that you could use and implement locally or basically integrate into your application and do the service discovery internally in your application or whatever you want to use, a library or something. And then AWS announced AppMesh. I reviewed that some time ago, and AppMesh is basically, it's the idea. So Envoy is a very popular network mesh, container mesh, open source project. And basically what AppMesh is doing is it's a service provided by AWS, integrating with ECS and I think even EKS. And it for Envoy, it basically is a backend for Envoy. And it's quite complicated to get up and running with that. So I tried it once during the review. It's a lot of resources that you need to configure, and you can really fine-grain to configure the service mesh actually. And now we have a fourth option, which is the ECS service discovery, and that's what I want to dive into in more detail now. The service discovery, ECS service discovery, basically combines two things that we already have. It combines Cloud Map, so Cloud Map is still involved, and then it deploys for you an Envoy container to each of your tasks automatically. So that's something we will talk about in more detail later, but I think that's a little uncommon. But basically, it also uses the Envoy open source project to achieve what it achieves. And basically what it does is it provides a service mesh. So what does that mean? So you deploy service A to ECS and service B to ECS, and then each container, each task running in your cluster can basically just by saying, I want to read service B, it just gets automatically forwarded to one of the containers of service B. And this happens by routing the request through the Envoy container that runs as a sidecar. And basically what the Envoy container is doing, it updates itself based on the records that are stored in Cloud Map. And the ECS service updates the records there automatically. So whenever a new task gets registered or deregistered, the Cloud Map is namespace, what it's called, is updated automatically. And one important difference to what we had before the service discovery feature is that this does not require DNS anymore. So you can use Cloud Map without DNS. So then it's basically just an HTTPS backend for service discovery, and that's what we need here. And the second advantage, I don't know if the advantage of not having to use DNS is such an issue, but okay, you don't need a DNS to do that anymore, fine. And the other benefit you get is you get standardized metrics and logs, because what Envoy is doing as it routes all the requests, it collects metrics about those requests for outbound and inbound requests. So it knows how long did it take to talk to service B and stuff like that, so you can debug stuff like latency issues and things more easily in a distributed system. So that's basically the idea. And as all the services and all the containers use Envoy, they use the same logging format, they collect the same metrics, so you get a standardized view over your service mesh and can monitor that more easily. So that's basically the idea behind that. Okay. Important thing to note quite at the beginning is that Service Connect works for inter-service communication only. So you cannot use that for connectivity coming out from the outside world. So it's not for connections from the internet or some clients connecting from outside. It's just for the cluster communication inside your cluster. And then, as I mentioned already, the service discovery deploys a container to your task. So it adds another container to each task that the service starts. So this is a little strange, I would say, because we don't have any control over that. So this is, this is a little interesting. And one aspect of what I find a little interesting here is, so when running on Fargate, you have to define the CPU and memory for each task. I think when running on EC2, this is optional. But how that works with this additional container that Service Connect adds to your task is, this Envoy container basically gets the leftover resources inside the task. So Michael, you have to proceed a little bit. I need to grab some water. Sorry.
Yes, sure. Yeah, I see, Andreas. And what I'm not 100% sure if this is actually also kind of part of Service Connect, and I was kind of looking it up before. But what you could, in theory, also get, or maybe they will add this, I don't know if it's already there, I can't find it anywhere. So I think the trick is, if you want to communicate with Service B from Service A, you now make a request to your local Envoy proxy. And this also means that this local Envoy proxy could, for example, implement a retry logic. So if it can't reach Service B, like instance 1, it can then try with instance 2 or task 2 in this case, and things like this. And I'm not sure if that's implemented, but that's possible in theory. And this is, I think, where things get cool, because then you can kind of remove logic from your application code, because this is then all handled by the proxy. And you can also, in theory, I don't know if they do it, but in theory you could have like very strong authentication, because the Envoy proxy knows the task, and you can get a identity document from the ECS metadata service, and you can then sign your requests basically. So the other side could only accept requests, for example, from Service A, but not from Service C and things like that. And then it gets very powerful, but I don't think that any of that is possible at the moment. Maybe you can correct me.
At least I haven't seen it, and
it.
I haven't read about it in the documentation, so I don't think it's available yet. Yeah, but you're right. That's what's possible in the future. Okay, sorry, I forgot to prepare Cluster Photo before the show. So basically, what I want to come back to this this task definition. So basically, they say, AWS says it's a feature that you do not need to modify the task definition for this service. That they just add that automatically when you launch the task. And basically, the Envoy container gets the leftover resources that you have not assigned to another container in the task. So basically, that's how it works. And I think this is a little strange because what happens? So I think there's no real guarantee that these resources are available, as far as I understand. This is kind of shared resources that this Envoy container is then using. You really cannot specify this directly to this task, or you have to kill the other containers if they consume more than what you have intended for them. So I think there's always a hard and a soft limit for both CPU and memory, as far as I know. And I think, this is a little strange, but that's how it works.
I think like the concept is very similar to what you can do with Kubernetes. So you can inject containers basically into tasks, or into, they don't call it task, but and I don't know if that's good or bad. I mean, okay, if you want to have full control, you better configure your task definition properly and things are working. But this is, I think, more for people that are a little bit, people who don't want to configure it everywhere, they just enable the feature and then boom, it works. And this is, it's always, if you it's implicit versus the explicit, right? So I don't know. I like to be kind of write everything down in my task definition, but other people don't. So I think for them, it's definitely more convenient to use it compared to what we had before.
Okay. Yeah, I agree. So the strange thing about this feature is it is a feature part of ECS, but then it runs inside your container basically on your infrastructure. And as always, I'm not
Yeah.
the biggest fan of those kinds of AWS features because they mix the responsibility. So when things are not working and I open a support ticket, so how will that work out? That's what I'm always a little skeptical about, because I assume that as AWS support cannot look into my container then, and they cannot really debug the issue. And I don't know nothing about how they configure it. So finding an issue there, debugging an issue there is probably quite complicated. And so I don't like the overall concept here, but that's how it is.
Yeah.
And yeah, so this morning I played around with the feature a little bit. So I think what is definitely a good thing about the new feature is it's very easy to use it. So compared to when I remember the first time I tried AWS App Mesh, this was really a lot of resources that you had to create, a lot of things you had to configure and get right. And with Service Discovery, it's quite simple to use that. So basically, so I reused our CloudFormation template for Fargate with CloudMap, and I reused that for Service Connect, and I basically had to change a few lines in our CloudFormation template to get that up and running. And what I get is basically the benefit of Envoy with the standardized monitoring, and I don't need to rely on DNS anymore. So that's what I get out of the box with a very simple setup. So I think compared to, if you look for a simple solution, and I think the Service Connect is probably a good choice compared to Service Discovery and App Mesh, which is quite complicated, and Service Discovery, which is relying on DNS and maybe a little outdated those days, I would say. Okay. But when I played around with it, actually I tried to find the promised standardized metrics and logs. And it turns out I found some of the CloudWatch metrics. What I found is the server side basically, or the service side, I see number of incoming requests, latency, error codes, stuff like that. So that worked. What I couldn't find, what didn't show up for me, I don't know why actually, I couldn't find the outgoing metrics. So for the requests outgoing of a service to another service. I don't know, this just was not showing up for me. I can't see why. And then the logs, the Envoy logs. So I could find logs from Envoy when basically the Envoy container was starting, but I expected that I also could see access logs. So basically the requests in the logs, and that is at least in my setup, not the case. So I just get Envoy was starting, the configuration of Envoy, but I couldn't find any access logs from the requests that are going through Envoy, which I expected for debugging purposes. So I don't know whether this is because the service is not working as expected or because of a misconfiguration. I could not find anything in the documentation that helped to solve that issue. So let's see. But this is going to. So that's
Okay,
basically
Andreas. All right. So the one that I picked is a announcement from the last week actually. So it's not from reInvent, and it's a very tiny thing, but it kind of touches something we talked about before here in the podcast or in the show. The announcement is that Amazon EC2 Autoscaling now supports metric math for target tracking policies. So what is a tracking policy or a target tracking policy? You have multiple options to auto-scale an auto-scaling group. So at the beginning, there was the way to basically when a CloudWatch alarm goes off, you can increase the number of instances or decrease it by an absolute or by a relative number. So that was the very simple first approach. And then they added step scaling, they added target tracking policies where you basically define, okay, I want to have this system to optimize my utilization based on this metric. So for example, you could say, okay, my CPU utilization of this auto-scaling group should be on average, like on average per host, per instance, should be 60%. And then what target tracking does, it adds and removes instances to kind of achieve the goal of 60%. And so you don't no longer need to define the thresholds when to add something or to remove something. You just define the goal. Okay, this is where you should optimize for. And this makes things much easier actually, because you don't have to figure out the thresholds. And what they implemented was that they had a very, I would say, short list of metrics that they supported. So for example, there was CPU utilization, I think it was network utilization, and I don't know, there was something else for EC2. And then they had for application load balancers, they had a metric for request count per target. So those were the built-in metrics. And when I say built, and this is basically a CloudWatch metric. So it just looks for CloudWatch metrics, and that you could use for target tracking. And what they then added was custom metrics. So you could specify custom metric, but it was like a single metric. So you had to, in most cases, this was like a metric that you have to publish in on your own. And now what basically the new thing is that you can use metric math to calculate this metric that is then used for target tracking, which kind of gives you more possibilities without publishing your own metric, which is, I mean, you have to write the code and execute it somewhere, maybe on Lambda or something. I mean, it's a lot of work for basically a very little difference that you make. So what I did, and also that's the use case that AWS actually describes as the standard use case for this new feature, is that you can now read like if you have an SQS based system where you have workers that consume messages, and you want to increase number of workers when a lot of messages are in the queue, and decrease when there are not so many messages in the queue. And what you can now do with metric math is you get a metric for the number of visible, like approximate number of visible messages in the queue. And then you need a second metric. Okay, how many workers do you have running? And if you use auto-scaling group, you can configure it in a way that it publishes for example, the healthy instances as a metric. So you can use the healthy instances metric. So you can then divide number of messages by healthy instances. And this basically is then the queue length per worker. And then you can use this as the target tracking metric. So in fact, you can say, okay, I want on average that each worker has only 10 messages in the queue, like for example. And that's kind of the use case here. One important thing, if you select the metric, I mean, you cannot just use any metric. The metric that you select must be a utilization metric, and it must kind of indicate the utilization of an instance. So a couple of examples that are not working is, for example, latency, and for example, age of the oldest message. So if you add a new instance to the pool, the age of the oldest message doesn't change. So basically, what the metric has to, the metric needs to be influenced by the number of workers that you have, basically. So that's important. And so there are actually not so many use cases where this is the case. So I was not able to come up with a good example. So I was like the ALB was a good one, but then I saw that's already supported by the old way of doing it, and I wasn't able to come up with something else. But SQS is a perfect example. And yeah, that's kind of it. A couple of things then that I kind of figure out when trying this out. Because we have Bucket AV, which is the S3 antivirus solution. It's SQS based and it uses EC2 to scan the files. And what we have at the moment is a so-called step scaling policy. So for example, when there are not so many messages in the queue, we add one instance. When there are many messages in the queue, we add 10, for example. I mean, it's a little bit more complicated than this, but this is an example for two different steps. So the more messages we have, the more aggressive we basically scale out. And so this is very important for people that run, for example, a weekly scan. So then within a couple of minutes, they add lots of messages to the queue. And with this aggressive scale out strategy, we can make sure that we then, like within a couple of minutes, really scale up the fleet significantly. And what I was trying to do is I want to kind of get rid of those logic, because those limits are actually not so easy to find. And also, I mean, there's basically no way to make this work for all kinds of workloads, because some people want to optimize for this, others optimize for this. So for example, some people want to have very, very low latency when they upload a file until it's scanned, while others want to maximize the utilization of the fleet and things like that. So it's a little bit hard to have kind of one size fits all solution. And I was hoping that this new target tracking possibility helps us a little bit to kind of find the sweet spot here. Or at least then we can say, okay, this is target tracking by AWS. So it's magic, and this is how it works. Yeah. So it kind of helps us a little bit to kind of solve that problem. And what I was stumbling into was a couple of things. So first, if one of your metrics goes to or is not published And this is, as far as I can see, the case for autoscaling groups with 0 instances. So if there are no instances in the autoscaling group, there is not a 0 published. That's the number, like the number 0. There's just nothing published to the matrix. And then you have no data. And if you have no data, then the alarm flips into insufficient data state. And if it's in an insufficient data state, nothing happens, basically. It doesn't scale in, it doesn't scale out, nothing happens. So that's not cool, but with metric math, you can solve the problem. So you can say, okay, if there is no data, you can fill it with a 0, for example. So there's a fill function. So I use the fill function, and then I always have like a zero line in my graph. So that was the first kind of thing I was running into. And then the other thing was, because I divide like number of messages by number of workers, right? But we scale down to 0, so I have to divide by 0 problem. So if I divide by 0, there's no number where it's published. It's like, I think it's none in not a number in CloudWatch as well. But this doesn't trigger the scaling. So I had to make sure that if the value is actually 0, then please divide by 1. Because otherwise I'm not able to kind of launch the first instance. So this was the second thing I was running into. And yeah, so there's also a function for that in CloudWatch metric math. There's an if function, so you can basically say if your metric is 0, then the value should be 1. Otherwise, take the value. So I used the if function here. So the fill function and the if function was important. And then I was running into another issue. So the third issue was that I want to my target should be the queue is empty. So I want to have the value 0 as my target. But if I enter the value 0, I get an error that the value is invalid. And then it prints me the boundaries, and it's a very, very low number and a very, very high number, but not 0. It's like very, very close to 0, but not 0. So 0 doesn't seem to be supported. I don't know. So I used then 0.0001 as my target value, and it worked. I don't know if that's a good approach or not. And the last issue, and I was running into this as well, is there is no support either in the UI or in CloudFormation to use the feature. So what you can do is you can use the CLI to use it. And so that's the only way to kind of make use of it at the moment. So the good news is it actually works. So as expected, when I add messages to my queue, instances are launched, and when all of them are kind of processed, instances are terminated. So it seems to work actually quite good. So I still have to do some like very heavy tests where like many messages are added at the same time and things like this. So I'm not completely done with my tests, but the tests that I did were actually looked very promising. And yeah, what I definitely have to do to kind of, before we can roll this out, Andreas, wait for CloudFormation support. And once it is available, I think we can just switch. It's like one last thing, Andreas, sorry for that. I was also hoping to get rid of the CloudWatch alarms. Because like we get many support requests where customers just tell us, okay, we can see an alarm in the CloudWatch UI that says here something is wrong, it's in alarm state. Because the customer doesn't tick the kind of hide auto-scaling alarms. And then they kind of are afraid that this is actually something very wrong with the system, but it's just the auto-scaling alert. And it's not bad, it actually just says, okay, do the scaling or don't do the scaling. And I was hoping to get rid of this, but it turns out that target tracking does nothing else than add 2 CloudWatch alarms into the system, and they are visible. So so they are still there after that change. I'm not very happy about that actually, but yeah. And the big problem is that you can actually mess around with them manually. So if someone kind of make just manual change to them, then the documentation says don't change them manually, but I don't know what happens if you actually do it, if they reset it or something. Yeah, that's not cool. I mean, I really, as you said before, I mean, I don't like all that stuff that AWS just, why do they do this in my account and let me see it? I mean, do it, but don't show it to anyone, and make sure that no one can edit it. And then I'm really annoyed by those kind of things. It's really not necessary. I mean, they could just do it properly. So just implement it properly.
Probably the easier way to implement it. And then.
Yeah, but it's really, I mean, if you can just make it kind of break it by, I mean, if people don't know what target tracking is, they just go there and change it, and then it's kind of broken. Yeah, I mean, that's shit. True. So.
Yeah. Okay, but still, this is a feature that we could use in the future when CloudFormation supports.
Yeah,
right?
we can use it. I definitely would like to use it as soon as we have CloudFormation support.
Cool.
So.
Okay, so those were the 2 announcements that we found interesting this week. Next, here's a message from our partners. Are you looking for a new job? AWS expertise is in high demand. Our partner TechRacer is hiring cloud consultants focusing on machine learning and analytics. So you should apply when you enjoy extracting insights out of huge amounts of data with services like Athena, EMR, SageMaker, or all the other analytics and ML services from AWS. Join TechRacer in Hanover, Duisburg, Frankfurt, Hamburg, Munich, Vienna, Lisbon, and Lucerne. And also, our partner Demicon is looking for a senior lead cloud consultant solution architect AWS, working remotely from Germany or the EU. Are you into infrastructure as code with Terraform and containers with ECS or ECS? Then this is for you. Demicon is one of the largest technical consulting teams and leading Atlassian full services providers in Germany. Become a part of their new team that is basically focusing on cloud technologies only. So they're building a new business unit, and you can be part of that when applying. You will find links to both job descriptions in the show notes. So if that sounds interesting, apply today. This is a good time of the year to look for new possibilities out there.
All right, Andreas, that sounds great. I have one lessons learned. I don't know. Do we have time to do that, or
Sure. Go ahead.
Yeah. So I mentioned in the pre-show that I worked on a feature for Marbot that in a nutshell, it runs Terraform apply every 6 hours. And I used the new Eventbridge scheduler to kind of fire every 6 hours. So whenever a customer enables the feature, we create a schedule for this customer, and we created actually what is called a fixed rate schedule. So this is, if you used Eventbridge before, this is where you say rate and then, for example, 1 hour, or in my case, I say rate 6 hours. So this basically, I'm not interested in the exact hour, exact minute. I just every 6 hours do it. So I don't care about what the exact time actually it runs. And I was kind of a little bit surprised when I first created the schedule. It immediately hit the target. So when you create it, it hits the target, and then after 6 hours it hits it again. So I was not 100% expecting that behavior actually, but it turns out that for us this is pretty cool because Andreas, I haven't told you that, but this is how I implement. If someone enables the feature, this is how I implement that. We run Terraform apply immediately when they create it. It's just kind of out of the box by scheduler. This is how it works. But I was confused. This was not what I expected. So I raised an AWS support ticket because by reading the docs, it's not really clearly mentioned. If you know that this is how it works, you can kind of, you could, maybe it's in the docs, maybe not. It's not clear. So I opened the support ticket and I asked them if I can rely on that behavior. And they told me, yes, I can rely on the behavior, which is cool. So keep that in mind. If you have a fixed rate scheduler, it will trigger immediately after creation.
And then every 6 hours after that, basically. In our case.
Exactly, yeah. Okay. And then basically it follows the sched or the rate, after that. Yeah.
That makes sense. Okay, very interesting.
That's it. That's what I learned, yeah.
Cool. Okay, so thanks a lot for listening. This was Hot Off the Cloud episode number 10. We will be back probably next week, hopefully, Michael. We haven't discussed that yet, but yeah, let's do it. Subscribe to our newsletter, podcast, or YouTube channel to make sure you're not missing the upcoming shows. And also, we want to thank our supporters who make this show possible. So please consider supporting our work as well with a recurring or one-time donation. You will find details and links to all of that in the show notes. Thanks a lot for your attention. Bye.
Thank you. Bye.